So here we are in Module 2, Section 2, and we're looking at our data analysis. With data analysis, there's a lot of terminology. Kind of go with your gut with a lot of these. Break down the words. Use a lot of your English decoding skills to help you with figuring out some words if maybe you're stuck a little bit. So we're talking about measures of central tendency first, and these are your middle numbers. So the three numbers we talk about a lot that are in the middle are the mean, the median, and the mode. And I'm sure in 5th or 6th grade you probably started to talk about these a little bit. Remember, the mean is the average. Okay, so you're going to take all the data and divide it by the number of numbers. Whereas your median is the middle number, that number that falls halfway between your maximum and your minimum. And then you've got your mode, which is the most frequently occurring number. And it could be anywhere. It doesn't necessarily have to be the middle number. With a mode, you could have a mode of 100 and your data ranges from 0 to 100. And just because you've got two numbers that are 100, that's your mode. It doesn't help us a lot in a situation like that, but your mode doesn't necessarily always fall where you want it to. So just kind of remember that a little bit. Then we've got range. And range is the spread of your data, so it's going to be your maximum minus your minimum. So if you've got numbers that have a range of 3, you've got they're pretty close together, whereas numbers that have a range or a data set that has a range of 100, the numbers are much further spread apart. So just think about test scores with a range of 5. That means all of our data is clumped within 5 points of one another. Whereas if it had a range of 100 and it was a test score out of 100 points, you've got somebody at the 0 and you've got somebody at the top at 100. So a range can tell you a lot about your data. And then we've got our quartiles and interquartile ranges, and I associate these kinds of terminology with box and whisker plots a lot. So with quartiles, you've got, think quartiles, quarter. You're going to break your data up into 4 quarters, okay? And so you've got the bottom half of data, all right? You've got the bottom half of data. So the middle of the bottom half of data is sometimes called the Q1 or the lower quartile. The median, that middle number, is your Q2. Okay, that's going to be your middle number. And then you've got Q3, which is the middle of the upper half of the data, the median of that upper half of data. So we also have another word we use when we're talking about these quartiles and things, and that's called the interquartile range. So what that's going to tell us is that's going to tell us that how big of a distribution our middle 50% of our data is. So if you look at the middle numbers, what's like that 75th percentile minus that 25th percentile, and that's going to give us our middle interquartile range. And we say you subtract the Q3 from the Q1 to get that interquartile range. Let's look at a few box and whisker plots. I think those are the best way to talk about our quartiles a little bit here. So here we've got a box and whisker plot, and what do we notice? So first of all, our minimum right here is going to be 10, and 90 is our maximum. Okay, so we can see 90 here, and so our range is going to be what? Our range is 90 minus the 10. So our range here is going to be 80. So 80 is the spread of our data. So then we look at our Q1. So right here at the edge of this box is the Q1. Okay, and that is the middle of the bottom 50% of data. That's a 1 there, okay? So that's the middle of the bottom 50% of data. And then we have our Q2, which is our median, okay? So that's the middle data. So our median here is going to be 60. And then we've got our Q3 right here, which is, again, the edge of that box, the top edge of that box, and that's going to be 70. So 50% of our data falls between here and here. So between 40 and 70, our 50% of our data is going to fall. So our IQR is going to be 30 because we subtract 70 minus 40. That's going to be our IQR here. So just a little bit about our box and whisker plots and how we use those quartiles for things. And then our median obviously is 60. Don't forget that. So a lot of times we talk about our 5-number summary of a set of data. So that's going to include your minimum and your maximum, your range, and then usually your median and your Q1 and Q3. So just think about those things as you are moving forward. Now we've got stem and leaf plots. Stem and leaf plots, I'm not sure why, but a lot of you are, it probably seems a little unfamiliar. So with stem and leaf plots, so you've got the stem. So think of this as like usually your tens unit, okay? Your tens unit. So this represents 70. 70 plus 9 is 79. And then you've got 84, 87, 88, 89. So this is a way, a stem and leaf plot is a way to kind of organize your data, show it from least to greatest a little bit, and go from there with a lot of your data. So I like, when I see a stem and leaf plot, my first thing I want to do is I want to copy down all my numbers and start to break it apart a little bit. So in this case, here's all of the data from my stem and leaf plot. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have 13 sets data points. So with that, half of that, so my 7th number, 1, 2, 3, 4, 5, 6, 7. So this number right here, this 98, is going to be my median. Okay, so I have 6 numbers below and 6 numbers above. Okay, so then if you want to find your Q1, which is going to be the middle number here, it's going to fall right between these two. So it's going to be 87.5. So if you don't have a middle number, then you have to average these 2 middle numbers together to get your Q1. And then we have to do the same thing with our upper half. So again, right here is going to fall our Q3. So those are the 3 numbers that kind of make our box. All right, those are the numbers that kind of make our box, my straight box there. And then our whiskers, if you want to think about box and whiskers, our whiskers extend all the way down to the minimum and all the way up to the maximum. So we can see here we have a range of what, 50? 124 minus 74. That's going to give us our range of 50. Now our IQR, on the other hand, we're going to have to take this Q3, which is 106.5, and subtract that from the 87.5 in order to get our IQR. Again, our median is 98. Sometimes that's referred to as the Q2. All right, moving on to probability. So we've got probability of events, and just simple probability is you take the number of favorable outcomes and you divide it by the total number of possible outcomes. Now with compound events, it gets a little bit more difficult because we've got independent and dependent. So independent is things like if you flip a coin and roll a number cube. Whatever you get on that coin doesn't necessarily have any effect on that number cube. Or if you're pulling a marble out of a bag, and that doesn't necessarily have any effect on, as long as you put the marble back in, it doesn't have any effect on what's going to happen next. So with something like dependent values, you're going to have what happens first really helps determine what's going to happen in the second event. So with both of these situations, you're going to multiply the individual events and the probability of the individual event. So if you look at like what's a probability of rolling a number, rolling numbers 1 through 4, okay, and then flipping a coin on tails. So if you think about that, the probability of the first event, numbers 1 through 4 are going to be 4 out of 6, right? So 4 out of 6 there, and then you're going to multiply that by the 1/2, which is the probability of flipping a tails. So if you multiply those two events, you end up simplifying that, and you get the probability of 1/3. That's going to be an independent event because what happened here really played no part in what was going on or what was going to happen in that second part. Now with dependent, it's going to be a little different, and I always like the socks, pulling the socks out of the drawer as a probability. So let's say you're looking for 2 red socks in your drawer, and you know you've got 2 red socks in the drawer and 10 blue socks. So you have a total of 12 socks. So the first time you reach in there, and it's completely dark, so you have no idea, you've got a 2 in 12 possibility of getting that red sock, right? So that first event really doesn't have any problems with it. However, the next event, that second event, now let's suppose that we got our red sock. How many socks are left in the drawer? Well, there's only 11 socks left in the drawer because you pulled 1 sock out already, and we're going to assume we got what we wanted. And so there's only 1 red sock left, and there's only 11 socks in total that are left in the drawer. So that's going to be a dependent event. Sometimes we refer to these independent and dependent as with replacement, which means you kind of put that sock back in there, or without replacement, where you don't put that sock back in there. So so just think about that as you're going. So in this case, we have our socks, our probability of pulling a red sock out the first time, which is 2 red socks out of 12. And then we're going to multiply that by 1 out of 11 because we don't have, we have 1 less sock in the drawer, and we're kind of assuming it's going to be red. So make sure that you also reduce your answers when you're talking about probability. So it's a 1 in 66 shot of getting 2 red socks when you pull 2 random socks from the drawer and you don't put the 1 back in. Okay, so then the final section here is just kind of looking at data a little bit and making some predictions. So if you think about, you may see in the keystones, you may see graphs, tables. So don't forget to look at a couple of things. Your labels here are going to be extremely important. So here's our days, and then these are the number of comic strips that are read, okay? So don't forget to read your labels when you're starting to kind of interpret some data and think about some things, because they're going to try to trick you. So in this case, if you look at this, so Jeremy paid attention to how many comic strips he read in the past 4 days. He plans to read 60 next Sunday through Wednesday. So if this trend continues and remains the same, how many comic books will he read on Monday? So so if you look at this, the first thing we need to do is this is the first kind of week, and so this is the trend that's happening. So he read 5 on Sunday, and then he read 10 on Monday and Tuesday, okay? And then Wednesday, he must have had a lot more free time because he read 15. So if you think about this, this week, he read in total, he read how many books? Or comic strips, I'm sorry. He read 40 total. Okay, and of those, how many did he read on Monday? 5, 10. He read 10 on Monday. Okay, so he read 10 on Monday out of the 40. But next week, he wants to read a few more. So he wants to read 60 total. So now I set up a new proportion. And again, they're telling us that the trend is going to continue. So we can then solve for x here using proportions, and you should get x is 15. So if he continues to read next Monday, he will read 15 instead of 10 because he's upping his game. So hope this helps. See you in video 3.